Good afternoon, my esteemed students, FGC Port Harcourt students, particularly Ss3 students. Good afternoon. I am here to deliver a lesson on mathematics. Do I need to introduce myself once more? You know me, I'm Mrs. Nwokocha, J.O., FGC Port Harcourt, maths teacher. I am here to deliver a lesson on mathematics. But before I go into the issue at stake, I will not fail to remind you of the existing problem throughout the whole world, particularly Nigeria. As we all know, we started these holidays unexpectedly. We began it when we are not supposed to begin it, and we have overstayed. The exam classes, Ss3 students and JS3 students, I want to seize this opportunity to remind you to be doing your homework, because as I understood, the moment this lockdown is called off now, I'm sure your exam will begin in earnest. And that's why we had the feelings to get in touch with you, to remind you that you have tasks ahead. We go into the lesson. The topic of the day is matrices. I have the objectives on the board. These objectives here are part of the objectives of this topic. The scope of this particular one is based on the 3 objectives listed on the board. At the end of this lesson, the following objectives will be achieved. 1. Students will be able to organize data and information in a rectangular array or matrix of rows and columns. 2. They will be able to add and subtract matrices of order up to 2 by 2. 3. Students will be able to multiply matrices by a scalar. Matrices definition. A matrix, plural matrices, is simply a set of numbers or elements arranged in a rectangular array or pattern. What do we mean by that? You are given a set of information. Maybe from statistics, you are given an information in a raw manner, and you need to organize the information. When you put them in the pattern of a rectangle, which we address as rectangular form, you are simply arranging it in what we call matrix. In the matrix below, there are 3 rows and 2 columns. We say that the order of the matrix is 3 by 2. The order of a matrix gives its size in terms of rows and columns. For you to tell us the order of a matrix, you have to mention the number of rows and the columns. And in mentioning the number of rows and columns, the number of rows is always written first, because it is the number of rows of a particular matrix that gives its name. Look at this example on the board. This is a matrix of order 3 by 2. Why is it order 3 by 2? It is order 3 by 2 because this matrix, remember what we call columns and rows. This matrix has 3 rows. Look at me. This is a row, This is a row. This is a row. Count 1, 2, 3. There are 3 rows. Columns, the vertical order of the elements. This is 1, 2. This matrix has 2 columns. That is why it is called 3 by 2. The 3 there is representing the number of rows, while 2 is representing the number of columns. The following below are some other examples of matrices. This matrix here is a 2 by 3 matrix because it has 2 rows. It has 2 rows and there are 3 columns. That's why it is called a 2 by 3 matrix. This matrix is a column matrix. Sorry, before I go to this column matrix, let me look at this first. This one has 6 elements. 1, 2, 3, 4, 5, 6. It has 6 elements. B is a column matrix. It is a column matrix because it has just 1 column. That's why it is called a column matrix. C is a row matrix. It has just 1 row. And there is something special about the row matrix. If you observe other matrices I have written on the board, this one is peculiar. It is peculiar in the sense that the elements of that row matrix are being separated by commas. This is another example. This has 2 rows and 2 columns. It has a special name. If by length you draw a shape here, you can see that it will give you a square because it has 2 rows, 2 columns. It is called a 2 by 2 square matrix. As I have explained, A is a 2 by 3 matrix and has 6 elements. B is a column matrix and has 2 elements. C is a row matrix and has 3 elements. D is a 2 by 2 square matrix of order 2 and has 4 elements. When I say of order 2, I'm sure all of us know why I said of order 2. It shows it has 2 rows. Notice that the elements of a row matrix are usually separated by commas. More examples. 1. State the orders of the following matrices. This is A. Look at that. We can observe that it has 2 rows and 5 columns. So that is order 2, a 2 by 5 matrix. This is a column matrix of order 1. This is 3 by 3 matrix. In other words, it is called a square matrix because it has 3 columns and 3 rows. This is a 3 by 2 matrix and this is a row matrix. This is another square matrix of order 2. Write down an example of a 3 by 5 matrix. B, a 2 by 4 matrix. C, a 4 by 2 matrix. D, a 4 by 4 matrix. Number 3, Write down a square matrix of order A1, B2, C3, D4. These questions are to be answered by students to make the understanding of matrices, the definition of matrices, more better. We now look at matrix addition and subtraction. The matrices below 1, 2 show the amount of food used by 3 families in 2 weeks. As we mentioned food, the numbers there can represent any food item. This is family 1, family 2, family 3. This is another second week consumption. To find the total amount of food used by families in the 2 weeks, add each number in one matrix to the corresponding number in the other matrix. As I said before, if we want to check the total consumption of the 3 families for the 2 weeks, it simply implies adding the elements of the first consumption, that is matrix, to the elements of the second one. So far it is done accordingly. Here is the addition. This, the first element in the first matrix, has its corresponding element in the second matrix as 15. Follow it in that order. You add, which shows this addition on the board. And the result is this. Matrices can only be added if they are of the same order. And the resulting matrix, that is the sum of 2 or more matrices that are added together, is also of that same order. At the end of the addition, the sum will still have the same order of the matrices added. Example 1. If A equals this matrix and B equals this matrix, you can see that I will be able to, according to the above explanation, I will be able to add these 2 matrices because they are of the same order. This is a square matrix of order 3, and this is also a square matrix of order 3. They can be added because each element in the first matrix has its corresponding element in the second matrix. But if their orders are different, some elements may not see what to be added to them. That's why they must be of the same order. Show that A plus B is equal to B plus A. You simply, solution goes this way. To prove this is a proof. You simply add the 2 matrices as they are added on the board. A plus B is giving this result. And B plus A is giving this result. You can see that the resulting matrix here is the same with the one here. If the solutions go that way, you simply conclude. You say, hence, A plus B equals B plus A. My dear students, remember that this theoretical question needs conclusion. If you answer this question and stop here and here, you are likely to miss an accuracy mark. This conclusion must be drawn for you to get the last A1. All right, we want to look at subtraction of matrices. The method of subtraction follows the same pattern as that for addition. For example, if it is required to find how much food the families use during the first week, Each number in the second matrix is taken from the corresponding number in the first matrix. And we put the solution as follows. You can see the sign of operation there is subtraction. We are minusing the consumption of the first week of the second family from this. And as we did in addition, the first element in this matrix is this. The first element in this is this. Take this away from that. As the name implies, corresponding numbers. You have this operation on the board, which will give us this result. This is the difference in the consumption of the three families in the first week. Example 2. Using the matrices A and B of example 1, show that A minus B is not equal to B minus A. Look at this sign. Some of us may not be able to remember in our inequalities. This sign, this is the first sign of inequality, which simply means is not equal to. Solution. To show that, carry out the two operations there. There are two operations. Carry out A minus B, which we have here. This is matrix A in example 1. This is matrix B. A minus B is this, which gives this result. While B minus A is this, and this is the difference. Now, looking at the two results, you can see that they are not the same. As I stated before, remember the emphasis of drawing conclusions on theoretical questions. You must draw it. Otherwise, I'm assuring you that failure to draw that mark is being deducted. Since they are not the same, after comparing, you see that they are not the same. You simply conclude that A minus B is not equal to B minus A. However, there's another way of telling us that the two are equal. And how do we do it? You simply negate the second operation. If you say that A minus B is equal to negative into B minus A, you have the same result. This is multiplying the second one by -1. Each element in the matrix must be multiplied by -1. When you multiply by that and carry out the operation of B minus A, you must get the same result with what you have there. More examples. Calculate the following. Number 1. Number 2. Students to solve. Use this and practice the addition and the multiplication of matrices we have planned. We now look at scalar multiplication of matrices. Example. As we look at this example on the board, the term scalar will be explained. If matrix A equals this stuff, find 3A. Solution. This is the given matrix in the question, 3A. 3A, A there is seen as an arbitrary or variable or an unknown, though a value has been assigned to it. The interpretation of 3A in algebra simply means 3 lots of A. 3 lots of A. This is algebraic term which can be interpreted as 3 times A. Being 3 lots of A, it can be A plus A plus A. You do substitution. Anywhere you see A, you leave the given matrix and put there, which is this plus this plus this. Adding, we have Add this and this, you get this. Then add the third one, which is this. And the sum will be equal to this. This process of repeated addition can be shortened. There's another short way of doing it. That is going direct to multiply the elements of the given matrix by the scalar. Here now you can see, even without being told the meaning of scalar, this is a numeral, ordinary number, which you are using to expand. When we say expand, it simply means you are using this 3, which is a scalar, to multiply term by term, element by element of the given matrix. And that is the short way of doing it. 3a equals 3. This is the 3 scalar into, you put the matrix. This is 3 times 2, 3 times x, this is 3 times 2, 3 times x, 3 times y, 3 times 0, which gives this result. Compare this with this, it will give you the same result. The number multiplying the matrix is called a scalar. To multiply a matrix by a scalar, multiply each element of the matrix by the scalar. Notice that scalar multiplication is simply repeated addition. Example 4. Find x if 5 into the matrix with elements 4, 3, 7, 3 minus 2 into the matrix with elements 1, 4, 3, 2 equals w, x, y, z. This operation has 2 steps. The first step is to simplify the left-hand side, which is marking even 3. I'm observing 3 solutions there. First one, you have to get the scalar multiplication of the matrices. Expand this with 5, expand this with 2, which will give this. This is 5 to multiply each element in this matrix, and 2 multiplies each element in this matrix. And this will result this minus this, which is equated to this 2 by 2 matrix with elements being variables. Now, the difference between this and this is this, and it is equated to. We have passed 2 steps of the solution of this problem. This is the final stage. Remember what we said about matrices being equal. 1, they must be of the same order. 2, they must have the same elements. Their corresponding elements must be equal. So, comparing that with this, it means W is equal to 18. X is equal to 7. Y equals 29. YZ equals 11. Since the final matrices are equal, corresponding elements must be equal, which implies that X is equal to 7. Notice that 2 matrices are equal if they are of the same order and their corresponding elements are equal. Take note of that. More examples. These examples, my dear students, I will leave you to practice with them. They are your assignments. Solve them as assignment at home. Thank you very much for listening. More examples. It will serve as an assignment to be solved by students. Number 1, if A equals this column matrix and B equals this 2 by 2 by 2 matrix, C equals that row matrix, and D equals another square matrix. Find A, 3A, B, 4B, C, negative 2C, D, half D, E, D plus 3B, F, D minus 3B. Number 2, find the matrix M that satisfies. Question A, M equals 3 into this matrix plus this. B, matrix with elements 9, 1, 2, 6 plus M equals matrix with elements 3, 7, 6, 8 minus M. Thank you very much. Please, I want to remind you that matrices, being one of the further maths topics that WAEC insisted that we should be teaching in ordinary maths, please take this lesson serious. Read your notes, consult your new general maths and some other maths materials you use, and pick some other questions in exercises in the book. Thank you very much. God bless you as you listen. I will remind you that the information from NCDC should be obeyed as regards the ongoing COVID-19. I will tell you that washing of your hands regularly with soap, wearing the face mask, using your hand sanitizer will go a long way to help us. We don't know what coronavirus is, and I pray God that it will not know us. Stay put. God bless you.